So 4-3 part 2 is super important. 4-3, 7-3 part 2 is super important. It used to be 7-3. Sorry if that says 4-3, but we have to make sure that we understand and know the unit circle by heart for the rest of the year. So it is a memory thing. We will have a memory quiz on Friday where you're going to have to duplicate what's called the unit circle. So we're going to be practicing it today. We're going to practice it tomorrow. We're going to keep practicing the unit circle so that Friday, hopefully, you'll be ready to go when we have a quiz over it. Okay, so what is the unit circle? So before we can use the unit circle, you might have noticed problem number 4 from the homework was a little bit funky. So we do have to talk about that. We do have to talk about something called a reference angle. So we have lots of little pieces that are getting us ready for the unit circle. So first, let's talk about reference angles. So do you see here our first angle? If we are in the first quadrant, our reference angle, which we're going to put a little prime by the theta, is the same as the actual angle that we have traveled. So to draw 45 degrees, right here is where our theta is, and that's actually equal to theta prime. So if we land in the first quadrant, the angle we get at is the angle we get. So we don't have to worry about anything funky. So reference angles for a first quadrant value, very nice. Now, for quadrant 2, we're going to have to reference the fact that the triangle will have just how far are we away from the 180 mark. So the rule of thumb is if it is in degree form, you just take 180 minus theta. If it is in radian measure, remember 180 and pi are the same things. 180 degrees is equal to pi radians. If it is in radian measure, you just take pi minus that radian measure. So let's look at 120. Now I'm going to show you what the triangle measure is. I'm going to show you what the real measure is. So we're going to do the reference and the real angle. Okay. So this is going to be approximate. So don't think this is going to be perfectly measured. But 120 the actual theta is right there. But we needed to build a triangle like we were doing in the notes yesterday. So the triangle is here. So the triangle, this is where your theta prime would go, because it always is that angle measure between the x-axis and the origin. And theta prime, if you land in the second quadrant, is just 180 minus 120. How much further do we have to go to get to 180? And so we have to go 60 degrees more. So the actual angle here in our triangle is 60 degrees. And then hopefully it should make sense because this is a straight angle. To get to there, we have to go 180 degrees. So this is 120, and then this is 60, gets us the rest of the way around. So when we build that triangle in the first quadrant, we're going to use 60 degrees to help us, even though our initial angle was 120. So sometimes we are going to relate it back to its reference angle very much. And the unit circle is going to teach us how to see those reference angles, hopefully very nicely, as we go through this process. So that's what we do if we land in the second quadrant. Now, what about if we land in the third quadrant? Now, I've been doing this a very long time. I've been teaching this a very long time. And even my brain does a little bit better in degree mode, okay? So this says 7 pi over 6 radians. I want to show you how to quickly change that into degrees. Every single pi is worth 180. So this is really just 7 times 180 divided by 6. That's just 7 times 180 divided by 6. Now, 6 does go into 180 30 times, so 7 times 30 is 210. So a 7 pi over 6 is the same as 210 degrees, okay? What's nice about radian measure is the reference angle is always related to the denominator that you see. So pi over 6 is 30 degrees. That is going to end up being our reference angle. So what's great about radian measure is the fact that the denominator kind of pops and shows you almost immediately how it's related to 180. So it's just going to be the pi over 6 is going to help us. But if you look at the rule that you need, if you land in the third quadrant, you have to take off 180 from it. So it's going to land here. And so we got to take off the 180 above it to find the reference. So let me show you what I mean. If we were to graph 210, it's approximately here. So our theta is 210 degrees, or 7 pi over 6. Our theta is 210 degrees, or 7 pi over 6. Our triangle is here. So our theta prime is going to be 210 minus 180. So in the triangle, we're actually going to have 30 degrees. Now, let's go back to radian measure because we have to start contemplating what radian measure is. Every pi is worth 180 degrees. I have 7 pi over 6, an improper fraction. I have a little more than 180 degrees. How much more? Well, 7 pi over 6 minus off of pi is 7 pi over 6 minus 6 pi over 6, or 1 pi over 6, which is indeed 30 degrees. So you are welcome at any time to convert it to degrees, do your math, and then come back to radians. Every 180 degrees is a pi. If you know that fact, it's just a ratio. I have 30 out of 180. I have 30 goes into 186 times pi over 6. Okay. So now, however you slice it, that angle in the triangle is 30 degrees. 180 plus 30 is 210. That would get me to the spot that would build that triangle. Okay. Does that make sense how I got that? Okay. Okay, now let's go if we land in quadrant 4. That's going to relate back to 360. So you have to take, how much more do we need to get to the 360 spot? How much more do we need to get to the 360 spot? So here is the rule you need. If it's in radian, we're going to take 360 minus the measure. I'm sorry, if it's in degrees, 360 minus the measure. 2 pi's is 360 degrees, so that's why you see that. Feel free at any time to convert to degrees and come back to radians. I tend to do that. So when I see pi over 3, I already know the reference is going to be 60. Now, I've been doing this, again, a million years, but pi over 3 is 60. Why is that? 180 divided by 3 is 60. And so that gives us, that's one great thing about radians. It kind of pops as to what the answer is going to be. But what is 5 pi over 3? Well, that's really 5 times 180 divided by 3. Well, 180 divided by 3 is 60. 60 times 5 is 300. So this is really 300 degrees. It's going to land us in quad 4. Let's draw a picture. There is theta, about 300 degrees. Again, these are just rough sketches of or 5 pi over 3s. I know that theta prime has to go here. I know it has to add up to 360. So I need 60 degrees. Pi over 3 is 60 degrees. But let's talk about the radian measure. 2 pi minus 5 pi over 3 is 6 pi over 3 minus 5 pi over 3. Didn't I tell you it would be pi over 3? Radian measure, the answer pops right out at you. The denominator with a pi is your answer every time as far as your reference angle. So anything that has a pi over 6 is related to 30. Anything that has a pi over 3 is related to 60. Anything that has a pi over 4 is related to 45. Anything that has a pi over 2 is related to 90. They're all related because of the fact that that's why radian measures were used, because it can relate what we know about circles, 2 pi r, and all that good stuff. Okay. So that is a little bit about reference angles. We're going to need that as we go to the paper and we build our unit circle. So let's talk about just sketching some things that look a little funky. You learned in 7.2, I believe it was, that positive directional change goes this way, negative goes clockwise. Okay. So let's draw. This is 0, 90, 180, 270. If we go backwards, this is negative 90, negative 180, negative 270, negative 360. Okay. Remember that two angles that land in the same spot are called coterminal. So 270 and negative 90 are coterminal. They land us in the same position. Negative 180 and positive 180 are coterminal. They land us in the same spot. Negative 270 and 90 are coterminal. They land us in the same spot. So if we graph negative 150, it would be between negative 180 and negative 90. So it's somewhat about there. It doesn't have to be perfect. But what is this reference angle? What is the angle actually in the triangle that we are going to use? Well, for a negative, so for a positive value, you're going to relate it back to 180 or 360. For a negative value, we're still going to do the same. Let's take 180 minus 150, and that's a way that we can see that it's 30 degrees in our triangle. Okay, so that's all they want to see for the first one there. 3 pi over 4. What's great about this is a radian measure. The reference angle is going to pop up and stare us in the face. The reference has to be pi over 4. Now, what is pi over 4? Well, pi is 180. If you divide it by 2, you get 90. Divide it by 2 again, you get 45. That's 45 degrees. So 3 pi over 4 relates to 45 degrees without even drawing it, because radian measure is so useful in that respect. But let's draw it. This is 0 radians. This is a half of a pi because it takes us a full pi to get to there. This is 3/2 of a pi, and this is 2 pi. Okay, so where is 3/4? That's 1/4, 2/4, 3/4. So 3/4 is right there. 3/4 of the way to pi. That's what 3 pi over 4 means. So our triangle, remember, you always connect it to the right, or to the x-axis. Our theta prime is right there. Guess what? It's pi over 4. So radians are actually nicer when it comes to reference because the reference angle is staring you in the face. So in this case, again, we could have changed it to degree measure. 3 pi over 4 is 3 times 180 divided by 4, which is 135 degrees. 180 minus 135 is indeed 45. However you slice it, you're getting 45. Okay. Now, if something is more than 520, or I'm sorry, more than 360, you got to take off 360 to see where does it really land me. Negatives aren't necessarily good. You can add 360s or 180s. But here, subtract off 360. You get 160 degrees. So we really need to see what 160 is. So here's 180. So 160 is a little bit like right there. And so this theta prime has to be 20 more degrees to get us where we need, right? 180 minus 160 is 20 degrees. So our reference angle, what is in our triangle? 20 degrees if we were to build a triangle. Okay, so that is a little about reference angles. We are going to break that down even more as we go through the process, okay? They're a little strange, but you'll see as we go, they'll be okay. Okay. So now let's talk about quadrantal angles. Number 4 from the problem that you had seen on the homework landed on a quadrant. That's what we consider a quadrantal angle, okay? And what's really cool is, let's go down the list. If we start at 0, you're always on a point R0. And so that is if you land here on the positive x-axis. 90 degrees is if you land on a point like 0R. If you land over here, it's going to be 180 if it's negative R0. And then if you land down here, that's going to be 270 or 0 negative R. Okay. Okay. Now, what I want to talk about here is, what does that tell us about the values? Now, remember, the sine is always y over r. The cosine is always x over r. The tangent is always y over x. Okay, so let's just do it for 0, and then I think it will help you. So let's say that we've landed at the point R0, like we did on the homework. It was the 0.20 was our homework for number 4. Okay. Well, what do? We have an x is 2. We have a 0. That's our x is 2. Our y is 0. Y is our r, also 2. Well, if you do the Pythagorean theorem, 2 squared plus 0 squared is the square root of 4. It goes right back to being 2. So that's why it ends up being that. But let's explore what our actual sine, cosine, and tangent values become for the homework problem number 4. Okay, so what is the sine of 0 degrees? So because that's where we landed on homework problem number 4. We were at the 0 degree spot. So the y value was 0. The x value was 2. If you were to put into your calculator the sine of 0 degrees, you always get 0. It is always that, no matter what the radius happens to be. Let's look at the cosine of 0. For the cosine of 0, we're going to get the x value over r. The cosine, if you put that into your calculator, the cosine of 0 degrees is always equal to 1. And then finally, the tangent of 0 degrees is always y value, 0, over the x value, 2 or 0. So no matter what, if you put into a calculator, what is the sine of 0? It is going to be 0. The cosine of 0 is always 1, and the tangent of 0 is always 0. So if you land in the 0 spot, so that would be right here. So if that was the 0.20, if you land there, you are going to always get the same thing. Whether you're at 2, 0 or 1, 0 or 4, 0 or 5, 0 or 7, 0, you're always going to get the same thing. Now, what do you do about the cosecant? Can you take the reciprocal of 0? What happens when you try to take the reciprocal of 0? It's undefined. So we will write that the cosecant is undefined at 0. If you try to put the sign into the calculator, you're going to get 0. Then you try to take the reciprocal of it, your calculator will say either domain error or no solution or something like that. Oh, that's neat. I don't know. I didn't know some calculators do that. That's cool. Okay. So let's talk about finding the exact value of the cosine of pi, the tangent of 450, and the cotangent of 7 pi over 2. So let's talk about A. If we land at pi, we're just going to say that we have landed at some point R0. I don't care what it is, some point R0. Now remember, the cosine is the x value over r. So we would get that the cosine of pi is r over r, or, well, that would be negative r, I'm sorry, because you would go in the negative direction. So it would be negative r over r, which is negative 1. Okay. So it would be negative r over r, which is negative 1. So if you put in radian measure into your calculator the cosine of pi, you're always going to get negative 1. If you put the cosine of 180, you're always going to get negative 1. It's just a thing. Now, 450 is more than 360, so we always need to relate it back to what it's coterminal with. So just subtract off 360. It is the same as 90 degrees. The point at 90 degrees is the point 0r. Okay. So what is the tangent? So the tangent of 90 degrees is the y value over the x value at that location. So the y value is r, the x value is 0, it is undefined. So if you were to put the tangent of 450 or the tangent of 90 into a calculator, it would say undefined. It would say, hey, that's not possible, that doesn't work, okay? So that is what you would expect for 450. 7 pi over 2. Every pi over 2 is 90 degrees, because that would be 180 divided by 2, or 90 degrees. So what would 7 of them be? Okay, so let's do a little rotation here around our circle. That's 1 pi over 2, 2 pi over 2, 3, 4, 5, 6, 7. So that's the same as 270. 270, always a point at that location, is always of the form 0, negative r. So what's cotangent? Cotangent is the flip of tangent, so instead of y over x, it's x over y. So the x value at that location is 0, the y value is negative r, so the cotangent of 7 pi over 2 is 0. You put that into your calculator in radian mode, you put the actual pi button, 7 pi divided by 2, you're going to get 0. Okay? So we're going to explore more of the quadrantals in a minute, but quadrantals are kind of neat. You can't build a triangle per se, you just have to do the y over x, x over r, y over r sort of notation. But I'm going to show you even a shortcut way than this in a second when we draw what's called the unit circle. Okay, so any questions on what we see there? Okay, so we're going to talk about today, what if we had a radius equal to 1? So think about the x over r would be x divided by 1. The y over r would be y divided by 1. The y over x would still be y over x. So what's cool about this is if we have a unit circle, a unit circle is just defined as a circle with 1 unit radius. Radius is 1. You always get some very wonderful results. The x value gives you the cosine at that location. The y value gives you the sine at that location. The tangent of that location is y over x, or sine over cosine. So we found some really nice facts that if we memorize the unit circle for multiple locations, we will immediately know the cosine and sine, and then we just have to make up a little fraction and we want the tangent at those locations. And then if we know the cosine, the sine, and the tangent, guess what we're going to learn? We're going to then be able to flip them over and we'll know all the reciprocals as well. Now, this is something you have to know by heart. We will have a memorization quiz over the paper that you have in front of you on Friday. It will be almost the identical paper that will be handed to you. Okay, it will be almost the exact identical paper. What we're going to do now is, if you could please, you need 4 colors: yellow, blue, red, and green, or something similar. I have some if you didn't have any. And now, could you please take out your paper copy? Please, there's a spot that says, I think, 7-3 unit circle. Could you please, at this time, take out your colored pencils? You'll still need a regular pencil, I think, too, and your paper copy of the unit circle. There's pencils on the back of the table. And we're going to build this. Now, I don't know how much further we'll get past this today, like actually using it, but I want to talk about how to build it. Okay. So first, in the top left corner, on the unit circle, the x value is always the cosine of theta. The y value is always the sine. Why is that? Because our x is the adjacent. The y is our hypotenuse. Oh, not our hypotenuse, I'm sorry, our opposite. And our radius is always 1. Our hypotenuse is always 1. That's what's great about a unit circle. The r is always 1. So we know that the tangent of theta is sine over cosine, or y over x. Okay, that will be on the quiz on Friday. You will have to know that information. Okay. So next, what I want to do is, if you could take out your yellow pen, highlighter, colored pencil for me. And it was kind of cut off slightly, but could we make the x-axis and the y-axis yellow for me, please? Could you make the x-axis and the y-axis yellow for me, please? So what we're going to start with is we're going to start out with our quadrantals. So make the x-axis and the y-axis yellow. Okay. Okay. So what we're going to do first is we're going to label the degrees going around our circle. So there's a little degree spot. So that's 0 degrees, 90 degrees, 180 degrees, 270 degrees. So I just labeled our degree measures: 0, 90, 180, and 270. Next, I would like to label the radian measures, okay? The radian measures are all related to pi. The radian measures are all related to pi. Pi is 180, pi is 180, pi is 180. Make yourself a note. Pi radians is 180 degrees. Okay. Now I'm going to try to show you the patterns so we can learn these patterns, because you'll need to have them memorized. Okay, let's start with 0. 0 degrees is the same as 0 radians. That's nice. Let's go across the way here. 180 degrees is pi radians. That's the one you have to memorize. How many times does 90 go into 180? How many times does 90 go into 180? Twice. So that's why this is pi over 2. We're going to use that like it's a fraction bar. Pi over 2. How many 90s are in 270? So that's 3 pi over 2. Now, if all else fails, you can do 270 pi over 180. You can do 270 pi over 180. If you reduce that, it's 3 pi over 2. But if you relate to 90, I have 3 of those. Don't you take 3 of those to get there? Okay. And then 360, let's put on here 360 is also 2 pi's. 360 is also 2 pi's. So now let's talk about our quadrantal x and y values. That's what these little point things are. Let's fill those in. The point, now this is a circle with radius 1. We're touching the circle. So this would have to be the point 1, 0. This would have to be the point 0, 1. This would have to be the point negative 1, 0. And this would have to be the point 0, negative 1. Now, why do we care? Why do we need that? How does that work? Well, if we are at the point 1, 0, I know at that location that the cosine of 0 is 1 and the sine of 0 is 0. At this location, I know that the cosine of 90 is 0 and the sine of 90 is 1. The x value is your cosine at that location. The y value is the sine at that location. Look at 180. The cosine of 180 is negative 1. The sine of 180 is 0. The cosine of 270 is 0. The cosine or the sine of 270 is negative 1. I know that without a calculator. From now on, for the rest of the year, you have to know that the sine of 270 is negative 1. You just have to know that. And that's what the unit circle is going to help us to memorize, okay? Okay, so now if you could get out your red pencil, please. Your red pencil. The littlest, or well, the widest x, the x that is closest to the x-axis, could you please draw that one? So it is the widest x, the one closest to the x-axis. Could you please highlight that one? So I usually do that one red, pink, something of that nature, okay? Now that location is 30 degrees. That location is 30 degrees, okay? Everything that I've highlighted in red is related to 30 degrees. 30 degrees, if you do 30 pi over 180, sorry, I was getting ahead of myself. How many times does 30 go into 180? No, 6. So it's pi over 6. Pi over 6. Pi over 6. 30 goes into 186 times, so that's 180 divided by 6, or pi over 6. Okay? Okay. Now, what is 30 degrees before hitting 180? 150, let's put it down. What is 30 degrees after 180? 210. Put it down. What is 30 degrees before I hit the 360 mark? 30 degrees before I hit the 360 mark. 330, let's put it down. Now let's do the radians everywhere. Everything's related to pi over 6. How many 30s are there in 150? 5. Right? 30 goes into 155 times, so that's 5 pi over 6s. 30 goes into 150 5 times, so that's 5 pi over 6s. How many times does 30 go into 210 or 3 go into 21? 7. That's 7 pi over 6s. How many times does 30 go into 330 or 3 go into 33? 11. That's 11 pi over 6s. It is always a ratio of 180. So if it's divisible by 30, it's going to have a pi over 6 in the bottom. So all pi over 6's from now on, you should always relate to 30 degrees. Every pi over 6 for the rest of eternity is related somehow to 30 degrees. Now, if you might recall back in the day, special triangles, there was a rule for 30, 60, 90 triangles. The one across from the 30 was always half of our hypotenuse. This hypotenuse on a unit circle is 1. What's half of 1? 1/2. So what's really cool is the one that's across from the 30 is always the opposite. Isn't this, look at our triangle, isn't the y value here bigger than the x value? From now on, you have to memorize the fact that the y value is 1/2, the x value is always square root of 3 over 2. And that's always from that special triangles, if you were due to the Pythagorean theorem, and if you knew everything about special triangles. The x value in this triangle, is longer than the y value. This is square root of 3 over 2. This is 1/2. Forever, hopefully, from this point forward, you will always know that the cosine of 30 degrees is square root of 3 over 2, and that the sine of 30 degrees is 1/2. The x is your cosine value at that location. The y is your sine value. How would you find the tangent? Well, we have to put y over x and reduce it down. But if you were to put in the calculator square root of 3 over 2, and look at that decimal, I think it's 0.7 something, and then you were to also put in cosine of 30, you'd get square root of 3 over 2. Same exact value. Okay, that's the exact value. Now, let's go over here. Now, let's talk about, see where it says positive, negative, okay? Let's talk about that for a minute. This is the positive quadrant. So in the first quadrant, everything is positive. So sine, cosine, tangent are all positive. Nothing is negative. Okay? Everything is positive. Nothing is negative. The sine, the cosine, tangent. So if your reference triangle lands in the first quadrant, your sine or your cosine will always be a positive value. But let's go over to our second quadrant. That is the negative positive quadrant. So in this particular case, the x value is negative, so our cosine is negative and our sine is positive. So tangent is sine over cosine, or y over x, so our tangent is also negative. So what's great about the triangle that was here, it's the exact triangle right here, except just make your x value negative. So we're going to just repeat those values. So you only have to have memorized the first quadrant, and we're going to repeat the same thing everywhere else. So that's negative square root of 3 over 2, positive 1/2. In our third quadrant, everything, well, not everything. The sine and the cosine are negative because that's our negative quadrant, but our tangent, since it's y over x, negative over negative, is a positive. So here, we're still going to use that square root of 3 over 2, 1/2, but now they're both negative in that bottom left quadrant. Let's go over to the fourth quadrant. In our fourth quadrant, the x's are positive, but the y's are negative. The x is our cosine, so our cosine is positive. Our sine is negative, so that means that our tangent is negative in that quadrant. So we're still going to use the square root of 3 over 2, 1/2, except make the square root of 3 over 2, it stays positive, but the y value, negative 1/2, goes negative. So now I know the cosine of 330 is square root of 3 over 2. The sine of 330 is negative 1/2 without using a calculator. That's why we use the unit circle, so that we don't have to use a calculator. Okay, so you should have now the 30 references all filled out. Could we please now get our green marker or pencil out and do the x that's smack dab in the middle? Please do the X in green, in the smack dab in the middle. Do the X's in green, that's smack dab in the middle. Are perfectly sliced down the middle. If we cut 90 in half, what do we get? 45. So this is 45 degrees. If you have a 45-45 right triangle, something interesting occurs. Both of our legs are the same length, right? It's an isosceles triangle. They both would have the same length. If your hypotenuse is 1 and your legs are the same, you always get square root of 2 over 2. So both the x and the y are square root of 2 over 2. How does 45 go into 180? Well, 90 goes into 180 2 times. So 45 goes into 180 4 times. So this is pi over 4. Let's go around our circle. 45 degrees away from 180 is a little funky, but just subtract. 180 minus 45 is 135. In that location, our x is negative, but our y is positive. So that would be negative square root of 2 over 2, positive square root of 2 over 2. 45 is this distance. 2 more of those, you'll see that that's 3 of those. Or you can divide. 45 goes into 135 3 times, so it's 3 pi over 4. So that's the 135 mark. Negative square root of 2 over 2, positive square root of 2 over 2 is the point. 3 pi over 4 is your radian measure. Now let's go in the third quadrant. If we add 45 to 180, you get 225. If you count the number of 45 wedges, 1, 2, 3, 4, that's 5 of those. 45 goes into 225 5 times, that's 5 pi over 4. That's negative square root of 2 over 2, negative square root of 2 over 2. That's 5 pi over 4, negative square root of 2 over 2, negative square root of 2 over 2. Let's keep going, because we have, we'll talk about this more tomorrow, but 45 away from 360, just subtract, you get 315. If you count the number of wedges, 1, 2, 3, 4, 5, 6, 7 pi over 4s are here. If you were to divide 45 into 315, you get 7. We're still going to use square root of 2 over 2, square root of 2 over 2, just make the x positive and the y negative. So that's our 7 pi over 4, our 315. Okay. Last one we want to do, please get your blue marker out. Please get your blue marker out and do that skinniest or tallest, however you want to think about it, x in blue. Do your tallest x in blue. Okay. Let's go in our first quadrant. That tallest x is 60 degrees. Let me show you a pattern that's happening. 30, 15, 15, 30. 30, 15, 15, 30. 30, 15, 15, 30. 30, 15, 15, 30. That does get you all the way around. So that pattern is consistent throughout. 30, 15, 15, 30, 30, 15, 15, 30. Okay. 60 degrees. 60 goes into 180. How many times? 3. So that's pi over 3. Take the same triangle that we built for the 30 and just flip it on its head. So instead of square root of 3 over 2 1/2, all you got to do is flip those over. That's 1/2 square root of 3 over 2. But look, doesn't that hit the 1/2 mark pretty darn good? So that hits 1/2 over, square root of 3 over 2 up. Okay. Now, so for time's sake, let's get these done. 180 or 60 degrees more is 120. That's 2 pi over 3. Instead of the positive positive, that's a negative positive in that quadrant. So make that a negative 1/2, a positive square root of 3 over 2. Make that a negative 1/2 and a positive square root of 3 over 2. Let's go down here. If we take 180 and we add 60 to it, that's 240. Aren't these 15 apart? 15 apart. 60 goes into 240 4 times. That's 4 pi over 3. This point is negative 1/2 negative square root of 3 over 2. That's 240. 4 pi over 3, negative 1/2 negative square root of 3 over 2. Let's do the last one here in the fourth quadrant. If we go to 70 plus 30, that's 300. 300. 240 plus 60, 300. Or if you can do the 30, that's 30 away. 270 plus 30 is 300. 60 goes into 300 5 times. That's 5 pi over 3. Your point is positive 1/2 negative square root of 3 over 2. Okay. Now, we haven't discussed how we are going to use this circle much. Okay. So please, at this time, take a picture of it. You want to have this in your camera roll on your iPad, and you're going to need to turn it in anyway. Bring this paper back tomorrow. Put your little stack of your 4 colors at the top of your desk so that the next person coming around can use them. This has to be memorized perfectly by Friday. So if you have to draw it out 17 times on a sheet of paper, so be it. We're going to draw it again tomorrow. Okay? We're going to discuss how to use it tomorrow. So please, 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 on the back table, I will put some little versions of extras. If you want to draw it again on your own, you can have a little extra one. I'll put that on the back table. There you go. We'll continue this tomorrow.